In this example, we're going to try to evaluate this integral. So it's the product of two functions, so e to the 8x times cosine 9x. So we want to use integration by parts. However, the procedure is going to be a little bit different because we're going to have to repeatedly apply it, and the list for differentiating does not terminate. It's going to repeat itself. And so, well, we're going to see how to deal with this situation. So we use the shortcut method. So first we decide on u and dv. So in this case, let's take u to be e to the 8x and dv to be cosine of 9x. So it actually doesn't matter which one we use to be u and dv in this case, because neither of them, when you continually differentiate, will go to 0, and they're both equally simple to integrate. So here we differentiate. And this side we integrate. So the derivative of e to the 8x would be 8 e to the 8x. And then the 8 just keeps coming down, and e to the 8x stays the same. Right, so then it'll be 64 e to the 8x and so on. So on this side we integrate, so the antiderivative cosine is sine. And then the antiderivative of sine is minus cosine. And then if you notice, if we keep trying to integrate, it'll repeat between sine and cosine. So we don't want to keep doing that. So what you want to look for is, here it's alternating between sine and cosine. And so the original thing that we chose for dv, cosine, has repeated itself with the minus sign, but that's not important. So the important thing is that the cosine has repeated. So we stop here. Okay, so now we put it together. So the first u times v will be this. The second u times v will be this with the minus sign. And then the v to u will be these two things. So the integration by parts formulas, because we have to repeat it twice, will look like u1 v1, the minus sign, minus u2 v2, and then plus the last part into a v3 du3. So putting it together, we have, so the left hand side, the integral of e to the 8x cosine 9x is equal to, so this times this, 1/9 e to the 8x sine 9x, and then minus this times this. The two minus signs actually cancel out, so it becomes plus 8/81 e to the 8x cosine 9x, and then the integral of this times this, so the plus and the minus becomes a minus. $64. So actually, let me pull the coefficient out to 64 over 81, integral of e to the 8x cosine 9x dx. If you notice, this here is the same as this. So what we do is we add this over to the left hand side. So you get 145 over 81, right? So 64 plus 81 is 145 times the integral of e to the 8x cosine 9x is equal to this thing on the right hand side. And so, to get the value of the integral, so we're doing it indirectly, you can just divide by the coefficient. You get the integral of e to the 8x cosine 9x dx is equal to 81 over 145 1/9 e to 8x sine 9x plus 8 over 81 e to 8x cosine 9x plus a constant. So now let's just simplify the coefficients. So 81 divided by 9 is 9. So you get 9 over 145 e to 8x sine 9x, and then 81 over 81 cancels out. So 8 over 145 e to 8x cosine 9x plus c. So the idea again is to use the shortcut method. So choose u and choose dv, differentiate down this side, integrate down this side, but stop when you see the function repeat itself, and then combine into the integration by parts formula in this way. So diagonally first, alternate the signs, and then this will be the last integral part here. So this times this, you put it right as an integral. And if you do that, you'll see that this part and this part are the same. So you can move this term to the left and find the value of the integral by dividing by the coefficient.